All right, another thrilling video about integral properties. This one is very important. It comes up all the time. In fact, I think it just goes without saying a lot of the time. People just assume that it's true. Proving that it's true is probably a much more challenging task. But what we're going to look at in this video is showing an example of why it's true. So if we look at this situation, we've got the integral from a to b of f of x plus or minus g of x dx. What we're saying is that that's going to be equal to the integral from a to b of f of x dx plus or minus the integral from a to b of g of x dx. Now, all that means is the integral of a sum of two functions is equal to the sum of the integrals. And you'll be sort of familiar with that from sort of earlier on in calculus because what you're with derivatives, because if you wanted to take the derivative of a sum of a few functions, you would just take each individual derivative and then add them together. The same is kind of true of integrals. So let's look at an example to make some sense of it. Let's imagine for a second that we've got the function f of x equals x cubed. So that's this blue line here. If we were to take the integral from, let's say, 1 to 2 of x cubed, we would get 15 on 4. So this area here is 15 on 4. And you can hopefully go off and prove that for yourself, but I can tell you that that's true. And then let's think of some other function, g of x, which is just the line y equals x. And let's also find the integral from 1 to 2. So we get an area of 3 on 2. Okay, what we're going to do now is we're going to sum those functions together. So we're going to create a new function that we're going to call f of x plus g of x, which is this sort of purple line here. Red and blue gives us purple. And so what we get is f of x plus g of x is x cubed plus x, just adding the functions together. And what this rule is claiming is that the area underneath this purple curve now between 1 and 2 will be equal to the sum of these two numbers, 15 on 4 plus 3 on 2. So let's take the integral of that. So what we have is the integral from 1 to 2 of x cubed plus x dx. That gives us an area of 21 on 4. And I suppose what our big conclusion here, the big finale of this, is that 15 on 4, so the area of the blue section, plus 3 on 2, gives us 21 on 4. So obviously there's not a proof, but it goes to show that if you are taking the integral of a sum of two functions, or more for that matter, then that's equal to the integral, the sum of the integrals. So interesting property there, very useful and very necessary to wrap your head around.